Hi Grade 12s, welcome to today's session. I'm Hayley. I'm going to be taking you through some data handling. We are focusing on paper 2 type questions. It's really important that you practice this section because it's a very big portion of your exam. So let's see what is involved. So like I said, we're doing data handling, and let's see our checklist. So what's our checklist? Make sure that you know how to, and we're going to go through these quickly, and then while we're doing the questions, keep this checklist in mind. So you need to make sure that you can do everything. So we need to be able to calculate the mean, the median, and the mode. So hopefully by the end of the session, we'll check that. We're going to work with quartiles. We're going to understand spread. Understand spread, that means it's the range, your highest minus your lowest, or your spread of your interquartile range. So it's all the spread of data. We need to understand which is the best average, and I'll come back to that if they don't ask this question. I can't remember if I've actually put one in today. And finally, we need to be able to draw the relevant graphs and also understand the graphs that they give you, because statistics often come down to graphs, or this data handling. Right, best thing to do, let's jump in and do some questions. So starting off with question 1, which comes out of our Feb-March 2013, paper 2, question 1.1. So the question says, the Olympic Games were held in London in the United Kingdom during the July-August 2012. In April of 2012, the school principals in Jacksonville decided to hold a mini Olympics in anticipation of the Olympic Games. And I'm sure this happens at all the schools. You probably experienced it too. As part of the mini Olympics, a diving competition was held between the schools. 2 divers, Bongani and Graham, were given the following scores by 9 diving judges after completing their dives. Now, I always like to read tables and interpret tables properly before I carry on with the questions. So we've got Bongani's scores, and he received 9.5, 9, 8, 9. Now, as I'm reading these numbers, it occurs to me that they are not in order. And I know when it comes to data handling, very often we need to put them in order. So I've already occurred to me that they're not in order. So carry on looking through these, and I see that I need to actually eventually put them into order. Graham's scores, on the other hand, were 9, 6.5, 9, okay, 7, and we carry on reading how many scores they had. I also like to check how many scores. We were told that there were 9 dives, so just double check. We got 2, 4, 6, 8, 9. So always double check the information. Use the scores to determine the following. Right, Bongani's median score. Now, median score, that is our middle value. So what do we need? We need to put Bongani's scores in order. So our first thing we need to do is put them in order. Remember, we didn't have them in order. So I'm going to look through them. They're 9 scores. It's not that hard to put into order. Either start at the smallest or biggest. It doesn't make a difference. So I'm going to go through his scores, and I'm going to look for the lowest number. So we've got 7.5, and cross them off as you go. Because if you need to, you can readjust, kind of rewrite it if you leave out one. Or don't just put a number on top. Rewrite the number. It actually makes it easier for your examiner to see. So we got 7.5, then I've got an 8, and then after that I've got 2 8.5s. And remember I'm going to leave out these commas. 8.5, and then how many 9s have I got? 1, 2, 3, 4. 1, 2, 3, 4 9s. And finally, 9.5. Now, what is important is double check that you've still got 9 values. So count them. I've got 2, 4, 6, 8, 9. But 9 values, chances are I haven't left anything out. I've also crossed them all off, so I know that I haven't left them out. And now we're looking for the median, which is our middle number, which we can literally use our hands, if you'd like to, and kind of highlight the bottom, the middle, and go towards the center. Alternatively, if there were 9 values, then I know it's 1, 2, 3, 4. It's the 5th value, and just double check that it's 1, 2, 3, 4, 5. It's the 5th value from both sides. So his median score is 9. So median in this case is 9. Perfect. We've done it perfectly. If you really feel like you need to leave out half the values, make sure that you've only got the first 5, that should be fine. So we could have left out the last 4 values, but I prefer to write it all out. I know that's what the memo has, and I know it's important that it's always nice when the memo and your question paper look exactly the same. Right, and then the question is, we want the range of Bongani's score. Remember, your range was your highest minus the lowest. So once we've got them in order, quite easy to see, our highest was 9.5, our lowest was 7.5. I don't think we need a calculator for that, but if you do and you'd like to take your calculator out, I haven't got a calculator, you want to take it out and say 9.5 minus 7.5, you are more than welcome to do that too. I also say to my kids, and I know it happens quite often, is that you think you can do it all in your head, but in an exam situation you tend to panic, you tend to stress. So rather use the calculator, even if it's just to check. Because I've had silly answers like 2 times 4 and I've been given the answer of 6. And I know it's just exam pressure. So know that you guys can do that. Rather use the calculator, you have it there. So our range is 2. Then it says, in diving competitions, there is a rule whereby a diver's highest and lowest scores are not considered. Give one valid reason why this rule is applied. Now remember, we are discussing the Olympic Games, and you need to give one valid reason. So what would a valid reason? We are excluding the highest value, and the lowest value. Now the highest value is going to absolutely increase our average, and the lowest value will decrease. So then what reason could there possibly be for us to say, well, let's take those 2 out? Now very often your highest value and your lowest value are what we call outliers. They might be very much higher or very much lower. Now if we look at Graham's data, for example, Graham's lowest was 6.5. His next lowest was 7.5. Now remember, Bongani's range was only 2. Now we look at Graham. Graham's 6.5 is way lower than the rest. So why are we deleting them? We need one valid reason. Now the other reason, we're dealing with the Olympics, and what happens is we have judges from different countries. So all our judges come from different countries. And this, different countries, and this means that there might be a bias among judges. So you might have a judge that particularly likes China, for example, and they're going to give the Chinese divers a better score. So what do? The highest score we eliminate. Or they might not like a country, and therefore they're going to be biased against the diver, and they're going to give them a low score. So how do we eliminate that? We say, well, highest and lowest are out. And then it makes it more fair. So it makes it a much less bias. So the reason is less bias because of judge, and how would we put that? The judge could like the country or dislike the country. So you know what, you can write that out yourself. But remember, it was one valid reason, and this is your opinion. And I love these type of questions in paper 2, and you find them quite often in paper 2, where you are giving your opinion. So give us your opinion, but explain it so that the actual examiner can see and understand what you've said and can allocate marks. It's very hard to get these marks wrong. Okay, let's see what our next question says. Determine, showing all calculations, which one of the 2 divers attains the higher mean score if the competition rule is applied. So we need to show all calculations. We need to work out our mean. So let's start off with Bongani. Let's change Bongani to yellow. So we're going to do Bongani's scores first. We are going to use the bias, the rule. So we are eliminating his lowest and his highest scores. So we're going to add the rest of the scores. So now I'm going to say 9 plus 8. Now, on your text, I'd actually like to see you say that it was 9 plus 8 plus, you don't have to write them all in, plus our last one was 8.5. But I do want you to always show this total. So let's get our calculator out and let's move our test board up a little bit. Let's get our calculator out and we need to add these up. So it was 9 plus 8 plus 9 plus 9 plus 9 plus 8.5 plus 8.5. Double check that you are entering the numbers as you're thinking of the numbers or as you're seeing the numbers. And we get an answer for that. It is 61. So now we must write that total down. So that was 61. I've got a pen. And we are dividing it by how many values did we have? Well, we've now eliminated 2, so we are down to 7 values. So always show that total. So in our calculator, divide by 7, and we get an answer of 8.714. Now, I'm not going to round to 2 decimal places in this case because I don't know what scores Graham's going to have. And it might come down to my 3rd or 4th decimal place. So I'm going to leave my decimal places. I'm actually going to write out 3 or 4. So I'm going to say 8.71428. 8.71. Right, and again, we're going to go through Graham's. And we're going to eliminate that we had, get rid of his lowest, and get rid of his highest. And now we're going to say 9 plus 9 plus 7.5. So I'd like to show that 9 plus 9. And the last one was a 9. But I'm going to give me that answer. So move back up. Let's get the calculator out. So it was 9 plus 9 plus 7.5 plus 8, 8.5, 9 and 9. 8 plus 8.5 plus 9 plus 9. Check that you've got it. And now we've got 60. So his answer was 60. Always, like I say, show that value. Still 7 scores. And we can quite clearly see that he has performed less well because we've got a lower number, but let's get our answer. 60 divided by 7. Let's check your calculator. 8.571428. So now, in this case, I don't need to carry on with a few decimal places. I can quite clearly see that Bongani performed better. And what did my question say? It says, determine showing all calculations. We've done the calculations. Which one of the 2 divers attained a higher mean score? So we now need to add to that. And don't leave that out. This is where it's important to reread your question. Don't leave out the fact that Bongani did better. Had a higher mean score. So it's really important because there'll be marks allocated for that, and those are marks that are like easy to lose. You think, oh, I've done the calculations, I've done everything, you've got it right, and you still don't get 100%. So reread the question. Right, let's see what our next question is. Question 2 has now been adapted again from the Feb-March 2013, paper 2. We got question 1.2. The competitors in the mini Olympics were awarded gold, silver, or bronze medals for, of course, first, second, or third positions, respectively. Each school in the competition, and remember this is based on the last question, remember they were having this competition amongst schools. So each school represented a country. The 3 schools representing China, Australia, and South Africa each won 23 medals. It's important to read the information, to understand what the information is telling us. So we're looking at table 1 now. These are medals awarded to the schools. We've got our schools that are representing these 3 countries. So we've got China, Australia, and South Africa. They have each got 23 medals, but they have been broken down differently. So China got 9 gold, 3 silver, and 11 bronze. South Africa, on the other hand, was 5 gold, 15 silver, and 3 bronze. So be able to interpret a table is really important. Look at the table. Now we understand the table, we can move on to the question. The organisers awarded 20 points for each gold medal, 10 points for each silver medal, and half the number of points of a silver medal for each bronze medal. Write down a formula which can be used to calculate the total number of points scored by a school, where G is the number of golds, S is the number of silver, and B is the number of bronze, in the form of. So this is the form they want us to write it in. So let's see, our total points is going to, points scored, is going to be, well, G is the number of gold medals. How much were we awarded for each gold medal? We were awarded 20 points. So it's G times 20 plus the silver medal times, how much were we awarded for the silver? 10 points for each silver. Plus, I'm going to carry on this side, the bronze points. And how much were we awarded for each bronze? We were awarded, this information here, half the number of points of a silver. So on the side here, I don't think we need to do that, but half of 10 is 5, so it is bronze times 5. Have we answered the question? We've given them a formula, given them an equation in the form they want, and that's perfect. So let's move on to the next part. Each principal claims that his or her school performed the best. Of course, like principals always do. My school is the best. In your opinion, now this again, your opinion. So you need to use the maths to substantiate your answer. But make a decision. Hard to mark you wrong if it is your opinion, as long as you can back it up. Which school performed the best? Show all calculations to motivate your answer. Now remember, it's also important to look at the numbers, the numbers of the questions. Now this is the second part of this first part, which was our formula. And normally when they ask you to derive a formula, they want you to use the formula. So we are going to use this formula to work out all our calculations. That is what we're going to use. We're going to use that formula that we have just written out. So we're going to have the total score, and let's just write it up as score, is actually 20 times the G plus 10 times the silver plus 5 times the bronze. So let's do our first school, represented China. China had 9 golds, 3 silver, and 11 bronze. So it was 9 gold, 3 silver, and 11 bronze. So we had our 9 times 20 plus our 3 times 10 plus our 11 times 5. And I hope that I haven't confused you in the fact that I've just written it the wrong way around here. Okay? So that's China. We're going to get a total. Let's do that calculation. It was 9 times 20 plus 3 times 10 plus, how many did they have? 11. 11 times 5. And we get an answer of 265 points. It's 265 points. Right, what was our next country? The next country we're looking at was Australia. Let's change our colors so we don't get confused. Australia. Now, how many of each did they have? So gold, we'll go back to our table. They had 8, 5, and 10. It was 8, 5, and 10. So it was 8 times 20 plus 5 times 10 plus 10 times 5. So in our calculator, we're going to do that in one step. Let's clear our calculator. 8 times 20 plus 5 times 10 plus 10 times 5. And they scored 260. 260 points. And finally, let's do our last one. I'll do it in pink. And we've got South Africa. Go back to our table. How many? They had 5, 15, and 3. There was 5, 15, and 3. Times by 20. 15 times 10 plus 3 times 5. And on our calculator, say 5 times 20 plus 15 times 10 plus 3 times 5, 265. Now that we've done all these calculations, we can use that to help motivate our answer. So these were, let me put their points in. Right, and the question said, in your opinion, which school performed the best? So, looking at our points, what do we notice? From our points, I'm trying to think what colour I haven't used. From our points, we see that Australia clearly got the lowest number of points. China and South Africa got the same number of points. So, we can actually say that China and SA performed equally well. Because they had the same number of points. But they didn't ask us for 2 schools that did well. They asked us for an opinion of which school performed the best overall. So now I'm going to say, well, that didn't help me out too much. I've got 2 schools. I've eliminated 1. So let's go back to my table and see, well, from my table, which is the best? Is gold the best? Is silver the best? Is bronze the best? I'm going to go with that gold is actually the best. So from our table, we can see that China actually had 9 gold compared to South Africa's 5. So I'm going to say, well, in actual fact, I think that China did better, China did best because of the more golds. They got more golds. Alternatively, and again, this is your opinion, why don't we say, well, okay, let's look at golds and silver. And say, well, if we look at the number of golds and silver, then we can say, well, South Africa got gold and silver, we got 20 gold and silver, whereas China only got 12 gold and silver. Their majority of theirs were actually bronze. So maybe South Africa did best. But you have to be able to substantiate your opinion. So it is your opinion, but you have to use the maths and the facts to get the answer right. So I think that I'm going to stick with China. But if you'd like, you can go on and say South Africa because there were more silver and golds. Hey, let's move on to the next question. Okay, so question 3 is adapted from the November 2012 paper 2, question 2.2. On the 14th of February 2012, there was a queue of customers waiting to eat at Danny's Diner, a popular eating place in Matutele. Can't pronounce that. The time in minutes that 16 of Danny's customers had to wait in the queue is given below. So we've got 30, 15, 45, 36. There's an A, which is a bit of a problem. 40, 34, B, 42, 26, and we carry on. So interpret the numbers. So first of all, we see that we have got them not in order. We've got an A and a B, a bit of a problem, but I guess the questions are going to ask us to solve them. And then it tells us that B is a value greater than 20. So now I want to make a note of that this is greater than 20. And all right, if you add to your tables, add to your notes, write out, highlight information, it's easier to not forget about it. Right, the first question says, the range of the waiting times was 37 minutes and the mean of the waiting time was 34 minutes. So those are important facts. Right, question 1 says, calculate the missing value A. A is the longest waiting time. Now we need to calculate that. So what do we know? We know the longest waiting time. We are dealing with the range. So we are going to say that our highest, which is our longest waiting time, minus our lowest, which is the least waiting time, is equal to 37. We know that from our range is 37 minutes. When we look at our numbers, can we see which is our, so we know this is the highest, we've just been told that, which is our lowest number, and we look through the values, we see that 15 is the lowest number. So we know the highest, which we still don't know what that is, minus 15 is actually equal to 37. So now how do I work out my highest? Well, I take my 15, I move it to the other side. Remember, change signs. So we're going to say my highest is actually my 37 plus 15. And you know what, guys? You've got a calculator. Use a calculator. So we've got 37 plus 15. Get an answer of 52 minutes. So that is 52 minutes. Now what I like to do as well is I like to add this. So this is now longer A. This is actually 52. And remember, don't panic about this. If you get the answer wrong for A, they will carry your mistake forward for the next questions. So as long as you see it is the highest, it needs to be the highest value. So if I got an answer of 12, there would be a problem. But as long as I've got an answer that is the highest number that I can see, then I should be fine, and they will carry your mistake forward. So don't panic. And it is 52, we've changed it to 52. Hence, calculate the value of B. Now, what do we have? We have two values of B, so I'm assuming that they are the same value. So let's work out, we've got 2B. We have got all our numbers. Now, how are we going to calculate B? And this, guys, is an important skill to be able to do. I can almost guarantee that a question like this will come up in your paper 2 type questions. Very popular question where we are given the mean. So we know what the mean is, and we know that our mean is we add them all up and we divide by 16, and we know that our mean was 34. Let me just double check. The mean was 34. So that is what we are doing. We are working backwards because we don't know what all those numbers are. So we're going to add the ones we have. We're going to add the ones we have. And we're going to add our B's, or 2 B's. We're going to divide by 16, and that's going to be equal to 34. So let's get that number, all the numbers that we have. Let's get our calculator out. And on our calculator, we're going to start adding these. We've got 30 plus 15 plus 45 plus 36 plus 52 plus 40 and 34. 40 plus 34 plus 42. Double check that you are actually entering the numbers correctly. 42 plus 26 plus 32, 38. Those last 3 values are 35, 41, and 28. 35, 41, and 28. And we get 494. So what do we know? We know this number now is 494. Plus we've got our 2 B's. Divided by 16 is equal to 34. So I'm first going to get rid of my 16. How am I going to get rid of the 16? I want to get rid of it. I'm going to times by 16 because then they cancel. So times by 16 there. So I've got 494. I'm sure I've got space here. 494 plus my 2 B's is equal to, let's get my calculator out, 34 times 16 is 544. That's 544. Let's move up here. So my 2 B's, I'm going to move that to the other side. So I'm going to say are equal to 544 minus 494. So I'm going to get my calculator out. So I'm minusing that 494. Check that you're entering what you want. And I get 50. So 2 B's are actually equal to 50 minutes. Therefore, 1B, we're going to, let's get a little bit of space, divide by 2 to get it on its own. So B equals to 25 minutes. Now go back and check. I can now enter this actually here as 25 minutes. 25 minutes. And B is a value greater than 20. It is. That's perfect. So we know we're probably on the right track. Great. Let's now determine the median waiting time. So now we need to place these all in order. And what I'm going to do now is I'm going to actually find a little bit of space next to this. Do it in rough on your paper first. I'm going to find, let's do an orange. We haven't used orange yet. And I'm going to place these in order. So I'm going to go through the list. So I'm going to write them here. So I've got 15, And then the next biggest value is, I've got crossed off 15, I've got 25. I've got a second 25, so those are those two values. Then we've got 26. I've got a 28. Next number I think is 30. We've got 32. We've got 36. No, I've got 34. 36. Now I've got a 35. 35, 36, and 38. I think I'm running out of space here. 40, 41. This is very systematically 42, 45, and 52. Double check. I've got 2, 4, 6, 8, 10, 12, 14, 16 numbers. Perfect. I've got them in order. Right, so now let's move them, and there we've got our values. Okay, so determine the median. Now we've got them in order, we need to find our middle number, and remember we've got 16 values, so 16 values is 8 on either side, so we can actually count this as 1, 2, 3, 4, 6, 7, 8. Need a pen for this. Was that 8? 2, 4, 6, 8. And just double check that you've got 8 on the other side. 2, 4, 6, 8. So our middle value is between these two, so don't forget we need to add them. 34 plus 35 and divide it by 2. And remember on your calculators, guys, your calculator will do BODMAS. So if we say 34 plus 35 divided by 2, we're going to end up with the wrong answer. Your answer needs to be in between these two values. Needs to be between 34 and 35. So if you get a number that's too big, then what mistake have we made? We have used BODMAS. So we need to either use your fractions or press equals. So either way, 34.5 is our answer. So we've got our answer of 34.5. That is our median waiting time. And this was minutes. Don't forget your units. Right, let's move on to the next part of the question. The question says, okay, we've read that. We know these values was 52. I'm just going to go back and put these values in, 25 and 25. Right, the lower quartile and the upper quartile of the waiting times are 27 minutes and 41.5 minutes respectively. How many of the 16 customers had to wait in the queue for a shorter time than the lower quartile? Right, those were the numbers that we had. So if I take those numbers, and I'm now looking at my lower quartile and my upper quartile. So let's just rewrite. We had our interquartile range was there. I'm not sure what this green line is. Let's just delete the green line. Our lower quartile is the median of the lower half. So that will be after 4 values. So that will be our lower quartile, which clearly we can see is 27. And our upper quartile is between 40 and 41, which is, no, sorry, 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Between 40 and 41. So I think we've made a mistake there. It should be 40.5. But the question is, how many customers had to wait in the queue for a shorter time than the lower quartile? So for shorter than 27 minutes, we had 4 people in the queue. So even though they've asked us about quartiles, they've given us those answers. How many was it? It was 4 people that had to wait less time than that. And how many people had to wait more than the upper quartile? Well, then we would count how many there are there, and it would be 4. Remember, we're dividing it into 4s every time, because there were 16 values. Right. Next part of our question says, Danny's previous record for 16 customers on the 7th of February 2012 showed that the median range and the mean of the waiting times were 10 minutes, 5 minutes, and 10 minutes respectively. Compare the statistics measured relating to the waiting times on the 7th and the 14th of February, and then identify 2 possible reasons to explain the difference in these times. So let us first take out the numbers from this, because there's a lot of numbers, there's a lot of words, and we tend to get confused. So what we're going to do is we are going to say we have the 7th. We are looking at the median, the range, and the mean. Right, so our median was 10, our range was 5, and our mean was 10, and these are all in minutes. Then we go to the 14th, and our median we calculated was, our range was 37, remember? Our mean was 34, and our median we calculated in the last question, to see what our median we calculated in the question before, was 34.5. Now, it says compare the statistics measured relating to the waiting times on the 7th and 14th and identify 2 possible reasons to explain these differences in waiting times. So, this again is your opinion. So we need to compare. Our median was much longer on the 14th. Our range was much longer on the 14th. And our mean was also much higher on the 14th. And now give 2 possible reasons. Well, what is the 14th of February? There's one possible reason straight away. 14th of February is Valentine's Day. Remember, we're dealing with a restaurant. So we've got Valentine's Day. Okay, so there's one reason straight away. Right, and this is a restaurant, so think about when would you wait longer for a table? There would be more people. So on the 7th of February, he had less people than he did on the 14th. So there's another reason. So we've got like less people on the 7th, less people on the 7th. And you know what, guys? You actually can go into any reason. I mean, honestly, why would you wait in a restaurant if it wasn't Valentine's Day? Maybe there was a problem with the power. Maybe there was no water. So think about it. Busyness. There's a lot of reasons. Make a decision and go with your decision. Just justify your decision so that the examiner understands what you are saying. Now, guys, on that note, I think it's time to take a bit of a break. So go off, get something to drink, stretch, but hurry back so we can finish with our data handling. Welcome back, grade 12s. I hope that you had a nice rest and that you actually just refreshed yourself and you are ready to go because I'm ready to teach. So let's move on to question 4. So question 4 is now adapted from the November 2012 paper again, paper 2 and question 2.2. So now we have the pie chart below shows the percentage of customers who ordered a different meal at Danny's Diner on the 14th of February. So we're looking at the heading, it tells us what the graph's all about. Percentage of customers who order different meals. And we've got our different meals. We've got chicken, beef at 20%, fish, let's see if we can get it in here, fish, lamb, and sausage. So those are the different meals that Danny's Diner was serving. Right, first question says, if 40 customers ordered beef meals, determine how many customers ordered chicken meals. So now we have, first of all, we have chicken meals that is missing a percentage. So we need to calculate how many people actually ordered as a percentage ordered chicken meals. So let's do that first. So we're going to do that and we're going to say, I'm going to actually do it right. Our chicken as a percentage will be 100% minus, and let's add the rest of these up, 20 plus 30 plus 25 plus 10. 20 plus 30 plus 25 plus 10. So we can add that up. That's it. Let's use the calculator. So 20 plus 30 plus 25 plus 10 is 85. We have 85 people that ordered other meals. So chicken is now represents 15% of the customers. Now the question says 40 customers ordered beef meals. So what we know, beef is ordered by 40 customers. How many people? It was 20% that ordered beef. Now we want to know how many customers ordered chicken if they represent 15%. Guys, this is clearly just a ratio. I've got 1, 2, 3 pieces of information and being asked for the fourth. So I can clearly just handle this exactly like I would a ratio. So I'm going to say, well, what do I do from here to get to there? I'm going to say times by 15 over 20. Remember, times by the second number over the first. So I'm going to say it's 40 times by 15 over 20. And let's use our calculator. 40 times 15 over 20. And we see that it's 30 people. 30 people ate chicken. There's a number of different ways that you can do this. You can work out what 1% of people were, if there were 40 people and they represent 20%, so 1% is 2 people, and you can do there's a lot of different ways that you can actually do this. We get our answer. I find ratio the easiest. I really do. Right. A customer is randomly selected. What is the probability that that customer would not have ordered a lamb meal? So we can do this two ways. We can either work out who did not have lamb, or we can say, well, okay, let's work out who did have lamb and then minus it from the total. So let's see now. We've got 40 people here. There were 30 people there. So we need to actually work out what percentage or how many people were actually at the restaurant. Lamb is 25%, or we can actually work it out as a 25%. We can work it out as a percentage. Lamb was 25%. So lamb was 25. So not lamb is clearly 100% minus our 25%, which is 75%. And we're looking at the probability at random, so we can say there's a 75% chance that that person would not have ordered meat, would not have ordered lamb. We can write it as a fraction, and we can actually simplify it, which your calculator will do for you, as 3 out of 4. So the probability was 3 out of 4. But remember, they didn't specify which way you need to write this probability. Probability can be answered as a percentage. So if you would have written it as 75%, they cannot mark you wrong. If you would have written it as a fraction, 75 over 100 would have been fine. And if you would have worked it out as 3 over 4, again fine. So it can be written either way, and they haven't asked. And this is where I like to reread the question again. What is the probability? They haven't asked which way they want us to give it to them. Right, let's move on to the next question, which is question 5. And this is now coming from the November 2012 paper, paper 2, question 5.3. Mr. Stanford was given the following graph by his sales director showing the percentage sales for each salesperson in 2011 and 2012. So we've got percentage of sales in 2011 and 2012. Now it's important to note that 2011 is the black with white dots and 2012 is the white with black dots. Okay, and we've got our percentages. So salesperson, we've got Cindy, Peter, Vivesh, Henry, Vanessa, Mabel, Temba, and Cole. And we can see our percentages. Percentages on this axis, we've got 10 up to 50. Right. So we understand the graph. Now can we use that to answer the questions? Interpret the change in the percentage sales for Vivesh from 2011 to 2012. Now what we have here is that we see 2011 ended there, which was at about, that's 15%, let's say that's about 12%. So that's about 12%. Then 2012 goes up to 40%. So what does this mean? It means that in 2012 we had the difference between 40 and 12%. So we can write this in 2011 he had 11%. That was 12%. In 2012 we actually had 40 minus 12%. Use our calculator, which is 28%. So we're looking at interpret the change in the percentage sales from Vivesh from 2011 to 2012. His sales increased, and they increased by actually quite a drastic amount. So his sales increased from 12% to 28%. The next question says, after he looked at the graph, Mr. Stanford identified Henry and Mabel as the two top salespersons for 2012, with a sale of 45% each. What error did Mr. Stanford make in his interpretation of the graphs? And explain your answer. Now, we go back to the graph and we see that each of them was on 45%. So where is his error? Now, remember, this is a compound graph. So this is based on 2011 and then 2012 on top of that. So for him to say that they have both achieved 45%, they have, but over the 2 years. So we need to identify, it says, what errors did he make in his interpretation of the graph? Explain your answer. So what is his interpretation? He did not look, he looked at once off. He did not see that they were, did not see that it was 2 years. Results for 2 years. Okay, he's saying they both did equally as well, but clearly you can see from this that Henry performed better in 2012, whereas Mabel performed better in 2011. So if you compare them, Henry did better. Henry is better in 2012, and Mabel was better in 2011. So it's important that you are able to see these graphs. And in paper 2 especially, guys, they often give you graphs that are misleading, ask you to correct them, ask you to change them, or ask you to interpret them. So this is a compound bar graph. So remember, it is one on top of the other. So we're dealing with the 2 years. Let's see what the next question is. It says, name 2 other types of graphs that the sales director could have used so that Mr. Stanford would not misinterpret the graph so easily. Okay, we could have used a multiple bar graph where the information is next to each other. So rather split up 2011 and 2012. So we could have used a multiple bar graph. I'm just going to draw that for you. Let's just look at it. So we could have had 2011 and 2012 next to each other. So let's say that's 2011 and that's 2012 next to each other, and then a gap, then the next person, 2011, 2012. Okay, I haven't done these values very well, but that's a multiple bar graph. Could he have used a pie chart? I don't know about a pie chart, but possibly then the best thing for him to do would actually to split it into 2 graphs. Okay, maybe so we could have had 2 graphs. Trying to think what other graph he could have had. So he could have had 2 graphs. And guys, again, this is your information. We could have maybe done a pie chart. Pie chart per year. That would have been easy to see which person did best in that particular year. So you've got your multiple bar graph, you've got 2 graphs, so in other words, separate them. We could have a pie chart per year. So there are lots of different things. They would have been easier to interpret than this graph. Right, so now let's move on to the last question for today. Right, question 6 comes out of the Feb-March 2011 paper 2, question 3.1. Miss Nana is the tourism teacher at the girls' school in Krugersdorp, Mogale City, Gauteng. She wanted to find out how many of the learners in her class groups had travelled in and around Krugersdorp and Mogale City to other places in Gauteng and to other provinces, respectively. She asked them to fill in the questionnaire below. I love it when they give you a questionnaire. Really nice, it's interesting, it's exciting stuff. So the travel questionnaire, complete this questionnaire by ticking the appropriate box, and it says only tick once. Where have you travelled? Only in and around Krugersdorp and Mogale City, in and around Krugersdorp, Mogale City, but also to other places in Gauteng, and in and around Krugersdorp, Mogale City, to other places in Gauteng, and also places in other provinces. So she's given them 3 easy questions, and you choose one of the 3. She summarized the data she collected as follows. So we've got the travelling data for Ms. Nana's learners, and she's got 3 classes, Class A, Class B, and Class C. Only in and around Mogale City, she's got 5, 4, 5. We've got 26. We've got 2 X's, a total of 98. In and around Mogale City and other provinces, we've got 16, 8, a third of X and Y. Now, I hate these X's and Y's, but we're going to have to deal with it because it came up in a question paper. So, calculate the missing values of X and Y. So, what do we have? First of all, let's tackle X. We know that X here is the same value, the same as our B was earlier. So we are dealing with 26 plus X is equal to 98 because that's our total. So we can add up our X's. So we've got 26 plus 2 of these X's is equal to 98. I'm going to move my 26 to the other side. So our 2x equals to 98 minus 26. And we've done this, guys. It's not so hard. 98 minus 26 is 72. So this is 2x is 72. And we get rid of the 2, get x on its own. And finally we get x equals to, 72 divided by 2, 36. I need a pen for this. Right, now we've worked out that, we can fill this in. That's 36, and that's 36. Now we've got a third of x, so we can take our 36 and times by a third or divide by 3, and we see that that's 12. So this is now 12. So finally we can work out what y is. So it's 16 plus 8 plus 12. So y was actually easy. Y equals 16 plus 8 plus 12. And you can do that on the calculator. Plus 8 plus 12. And it's 36. There you go. Calculated the missing values of x and y. There are 48 learners in Class A. So we know that there are 48 learners in Class A. Give one possible reason why the total number of learners in Class A in Table 4 above does not correspond with the actual number of learners in the class. So where's our Class A? Class A, if we add these up, let's add these up. 5 plus 26. 5 plus 26 plus 16 gives me 47. That is actually 47. But we all know there are 48 and give one possible reason why that total number of learners in Class A in the table does not correspond with the actual number of learners in the class. Well, guys, how many of you have been at school every single day? So if this survey was done on a particular day that you were absent, then the class wouldn't add up to the total number in the class. And I know as a teacher that very seldom do I actually have a full complement of every single kid in every single one of my classes. There's always somebody sick. So that would be a good reason. So somebody was absent. What's another reason? We could think of 100 reasons off the top of my head. Another reason, one child refused to answer. One child was in the principal's office, went to the bathroom, There's a lot of reasons. So we're looking for one possible reason why the total number of learners in the table does not correspond with the actual number in the class, and that is something that you guys ask in your opinion, you give your opinion, and justify your opinion. So I do want to see here that the total in the class, the total from the table, is actually 47. The total from the class is 48. So I do want to see that you've actually done the maths of it. So remember, guys, when you've got an opinion, make a decision. Use your opinion. It is your opinion, but base it on maths. And guys, that takes us to the end of the session. I hope that it's helped. I hope that you remember your checklist that we did right in the beginning. Practice, practice, practice. Read your question, reread your question, and remember, whenever you're dealing with data, with a lot of data, do the calculation and then go back and recheck your calculation. It's very easy to type in the wrong number on the calculator, the wrong number to come up. So double check, and remember, when it's your own opinion, have an opinion, base it on the maths, and show the examiner what you are doing, and work logically. If you work logically, then your examiner can actually follow your train of thought, and that's great. And otherwise, just practice this a lot, and good luck for the exams.